Hello and welcome to the 8th session of Java video series. In this session we will understand about the types of variables in Java. So there are basically two types of division in categorizing variables inside Java. Division 1 states that based on type of value represented by a variable, all variables are divided into two types. So the type of value, alright. So say we have primitive variables. We know that primitive variables are int, short, byte, long, and then there is float, double, and we have what's that, boolean, and these are all types of primitive variables. So when I declare int, it's int x equals to 10. Actually it's a mistyping. Please consider this as int x is equals to 10. So that can be used to represent primitive values, right? So int x equals to 10. So x over here means x is a primitive variable because we are using primitive data type or primitive keyword, primitive values. So that's why type 1 is primitive values, right? Division 1 states that type of value represented by variable. So the variable which is representing the type of value is primitive variables. The other one is the reference variable. So what basically is a reference variable is we have not studied so far. We will be discussing about reference variables when we will be discussing about the objects inside Java. But to cover the point, we know that from the topics of arrays that to create arrays we required new operator to create the arrays. And from the discussion of arrays we know that arrays are objects. So to create objects we require new keyword. When we use new keyword, then we create objects. So in order to understand the reference variable, consider a scenario where I create an object of type, say, student. Now the type of student means that the student must have a name, so there must be some kind of declaration in which we can store the name of the student. So for that particular data type we can declare string name of the student, so that will be storing the name of the student. We can declare that type as an array type because there are a number of students inside a class or inside a university's course. And then there will be other properties related to students such as their roll numbers and their address, phone numbers, etc. Besides that, we have to calculate certain things related to students such as their attendance, their performance in the sessionals or in the semester examinations, and then we have to give them marks or grade systems, whatever is applicable. So in this way we define a whole lot about the students, and we collect all these information inside class, which is a part of Java language. So class contains all the information about student. So if I say that I create an object of type student, it means that particular object will have all those properties affiliated to it. It means it may not be using that, but if it wanted to use those properties which are defined inside that class, so it can use those properties, right? So that is what an object is. So an object, you have defined something such as a student, and then you created an object of that type. It means that the properties that were defined by you in the class of student will be possessed by the objects when you create an object of that type, such as when you create an object of type student. So to create an object of type student, what you have to do, you have to simply write new, the keyword. It's also an operator, new the keyword, and then you have to write student, right? Then you have to write student followed by two braces, the braces which are available on the key 9 and 0, right? Those braces. So this will create a new object of type student. But say you have a car and you don't have control of that car, so that car is of no use to you. It will be an object of accident for you. So similarly, when you create an object, you must have control over that object. So in order to have the control over that object, we must have some kind of steering, such as in case of car, we must have a steering to control the car. So reference variable is that kind of steering which gives us control over that object. So we create an object, and to control that particular object we use reference variables. So to create a reference variable, it must be equivalent to the particular type of object that we create. For example, if I'm creating an object of type student, then I must have the reference variable which must have the capacity to address the student type of object. So when I'm going to use this reference variable, then I will write student. Of course, cases must be same because Java is case sensitive. We have discussed about this point in the previous video sessions. So cases must be same. So student, right? Student, and then any suitable name, any suitable identifier name. We have discussed about identifiers as well in the previous sessions. If you have not watched those sessions, please do that, and do watch these sessions, or if you have the knowledge, you may proceed with this session. So if we are talking about reference variable, so they can be used to refer to objects, right? And I have explained this. Student S over here, S means that it's a reference variable. It has the power to reference to an object. This is an object of type student, right? So this particular reference is referring to this particular type of an object. Say I say student S1, and then I try to give this particular object to S1, then it's perfectly alright. Student S1 will have the capacity to point to this object S1. This is object type of student, right? So there are two types of variables based on the value represented by them, right? Primitive variable, it means we are using primitive data types, and then reference variables, when we are using variables which can refer to objects, right? So these are two particular cases of division 1. Now let's talk about the division 2. In division 2, we classify based on the position of declaration and behavior, right? What is the position of the declaration of the particular variable? Like it is inside the method, or it is inside a particular block, or is it inside the constructor, or is it inside the class and not related to any kind of methods or constructors or blocks. That is somewhat the relation of the position with the variable. We will be studying about this in a great detail very soon. So, and behavior, right? And what's the behavior related to that? So all variables are divided into 3 types. So based on their position of declaration and behavior, variables are of 3 types. First is instance variable, second is static variable, and third one is local variable, right? So easy names: instance, static, and local. Easy to pronounce at least. Now let's talk about the first one, the instance variable. So instance variable, so let's begin with the definition. If the value of a variable is varied from object to object, it means, say if I am creating an object of a particular class, say student is a class, and I want to create object of type student, then I will write student S1 equals to new student. So S1 will be a reference object, and it will be pointing to that student object, right? So we will say S1 is an object of type student, right? So S1 is student type, but it's one object. Then student S2 equals to new student. It means S2 is another student object, right? It has same property as S1, but S2 is another student object, right? Okay. So such type of variables are called instance variable. What we have to realize is that creating S1 and S2 for students, the value of variable is varied from object to object, right? Such type of variable are called instance variables. So let's talk about this point a little bit. So okay, see this example. We have class test. It means we can create objects of type test, and then we have a variable over here, right? Consider for now that this is an instance variable. How to identify that whether a variable is instance variable or not, we will be discussing very soon. But for now, consider this as an instance variable. Also, it is an instance variable as well. So this is an instance variable. Then this is a method, right? Public static void main. Because static keyword is there, then it means that it is a static method. Alright, because static keyword is there, it means it is a static keyword. What are the properties associated with static methods and all other things related we will be discussing when we will be discussing about the methods, right? So let's move on further. These curly braces are part of syntax. Over here, these curly braces are all part of syntax. Okay. So before really beginning with the definition of the method, we must specify curly brace, or before really beginning with the definition of a class, we must specify curly brace. So this is part of the syntax, right? This is essential. If we are not going to write down this, compiler will flag error. So then we are creating object of type test, right? And then we have a reference variable that through which we can hold this object of type test. What we are doing over here is, after creating the object, we have changed it. So because we have created an object over here, it means this object will have an x equals to 10, right? This object will have an x equals to 10, and if I want to print the x, then I will have to use this reference, alright, this reference to print x. So this reference contains this. So we use t.x. To pinpoint to members, we use the object, then dot, and then the member, right? t.x equals to 20. So what we have done here is we have changed the value of x from 10 to 20, right? So if I print the value, I will get 20 over here. So it will be at 20 over here. Then if I again try to create another object of type test, then what I am doing over here is I am giving a reference variable to another test object, right? Here t is holding reference to one test object, t1 is holding reference to another test object. So there are basically two test objects. T1 and T2 are pointing to different test objects, right? Then what we are doing over here is we are trying to print the values. So say if variables are not associated, or say if variables are associated with object creation, then it means if T1 is changing the value over here from x equals to 10 to x equals to 20, then T2 should reflect that value. It means after creating T2, it should be 20 over here. But if it is not, then it means it's an instance variable, because instance variables have different copies of their variables, right? When they are created inside, when an object is created, right? When an object is created, instance variable will have their own copies related to objects. So T1 will have his own copy of x, and T will have his own copy of x. So if any changes are done by T inside x, then it will not be reflected to T1, right? This point being said, let's just plainly run this point and see if this is really working out. So I have already copied down this code over here, and I have also saved it. So let's quickly run this and see if this is really working. Java C test.java, and we see that there is no compile time error, and then run it and we see 20 and 10. It means first print statement gives 20, so T has changed the value of x to 20, but second object is not recognizing any kind of change in value of x, and it's printing plainly the 10. So this is first point. It means it's a kind of instance variable. Now for every object, a separate copy of instance variable will be created. This is the point which I have proved. So if a variable is varied from object to object, such type of variables are called instance variables. So for T1 value was 20, for T the value was 20, but for T1 the value remains same. So the value is varying from object to object. So it means it was an instance variable, again proving the point. We have studied this point. For every object, a separate copy of instance variable will be created. Then instance variable should be declared within the class directly, but outside of any method or block or constructor. So this is the definition through which we can identify the instance variables. To understand this point further, let's just discuss this definition. Method is something we have discussed in the right now. So method cannot contain instance variable. If it is inside, if there is a variable inside the method body, then it's not an instance variable. Whether the method is static or non-static, it doesn't have to do with that. Instance variables cannot be created inside methods or block. Block is something which comes under curly braces. So we have curly braces related to class, then we have test, then a curly brace, right? Then we are having a curly brace, but that curly brace is part of the syntax. Similarly, curly braces related to methods are part of the syntax. Other than those curly braces, if we are specially defining curly braces at any part of the code, they are called as blocks. They can be static blocks, they can be non-static blocks. How to declare them, how to use them, it's other part of the discussion. So they are called blocks. Now constructors are also a big topic, but for the introductory purpose, constructor is a type of method. Actually, it's not a method, but for now consider it a type of method which has the same name as the name of the class, right? So if I am defining class test and I want to write constructor for class test, then I must write the constructor as test, right? I must write the constructor as test. If I am trying to write any other name and try to say that it is a constructor, this will be wrong. The Java compiler is not going to understand that it is okay, it's a constructor. And to understand the point better, consider the example over here. See, this example is using a constructor because name of the class and name over here is same. It's using a constructor, right? A constructor is something like this. We just write down the name, right, with curly braces on and brackets like this. All right. So this is a constructor for class test. This is a constructor for class test. It has the same name. Constructor has return types or not, we will be discussing in the later video sessions, right? What are the permissible return types available? What are the permissible modifiers that are available with the constructors are some of the very important topics related to Java, and they are asked very much in the interview rooms as well as in major examinations. So this is constructor, right? And we are over here using constructor to create objects. We are using constructor over here and over here to create objects. So this is about constructor. So constructor or the method or the block, right? They inside them, if any kind of variable is declared, then we shall not tell that the particular variable is instance variable. So instance variable should be declared within the class only, right? But outside of any method or block or constructor. So if we again see the code over here, we see that this variable is not inside any method. This is the method and this is outside this method. Then there is no constructor which is encapsulating this variable, right? And there is no block as well, static or non-static. There is no block which is encapsulating this variable declaration. So this is basically an instance variable. This qualifies the definition of instance variables, and hence it is an instance variable. Now going further with the points, how can we access instance variables? Say when we are inside a static area. Static area is something where static keyword is used. In this method we are using static keyword. So all this area is a static area or static context, right? We cannot access instance variable by its name inside static area. Again, we cannot access instance variable inside static area or static context. So how to access the instance variable inside static context if we cannot use the name? Well, we have to first create the object of type test like here, and then we have to use the reference variable, and with the help of reference variable we can access the value or the instance variable x, like here I did. So this is the way you can access the instance variable inside the static context. And say if we are not inside static context, it means we are out of static context or non-static area or non-static context, then we can plainly use the name of the variable, and this will be very well fine with the compiler and it's not going to give any kind of error. So here is one point related to the access of instance variables. So class test over here, and then this is an instance variable. It's not declared inside any kind of method or constructor or blocks, right? Then this is a static method. Main is a static method, right? And then I'm trying to print the value of x. It's gonna give me an error. Non-static variable x, right? It's non-static, cannot be accessed from static context. This will be the error flagged by the compiler when I will try to execute this statement. Rest, what I'm trying to do, I have done a creation of the test variable, reference variable in the static area, and then it's permissible, and then I have tried to access the variable using the reference variable of the test type. So it will print 10 over here. In the non-static context, because there is no static keyword associated with this method, so it's a non-static method, right? We can plainly use the name of the variable over here, and it's gonna give very much the value of 10 over here. So if I copy down this code and paste it over here in the demonstration file, saving the code, and after saving the code I have to recompile it and see if it's not giving any kind of error, and it's gonna print 10, right? Which is this, okay, which is this. And if I uncomment this line, save the code, then it's gonna give the errors which I have stated onto the screen. So let's just run this code and we'll see the error. Okay, 10 errors. Non-static x cannot be accessed from this, blah blah blah. 10 errors screaming. Why? I don't know. Maybe every dot and every other thing will be considered. Anyway, the core error is same. We have this as we have discussed. So talking about instance variable will be created at the time of object creation and destroyed at the time of object destruction. So how instance variables will be created? When we create an object. As soon as we create the object, the instance variable get associated with that particular object. And when the work of object is done with the code, or it is no longer used or associated with the code, then the garbage is going to throw that object out. And similarly with the collection of the object for garbage, the instance variable will also be destroyed automatically. So scope of instance variable is basically the scope of the object. So this is one thing. Instance variable will be stored in the heap memory as part of the object. So Java compiler has 5 areas to store different parts of the Java source file, right? And one of the area is heap memory. So instance variable is stored in the heap memory as part of the object. We will be discussing about the architecture of the Java compiler in the later video sessions, or I think it will be the last session that I will be discussing Java architecture, JVM architecture, right? But for now, instance variables are stored in the heap memory area as part of the object. We cannot access instance variable directly from static area, but we can access by using object reference. We have discussed this point. So to access instance variables, we have to create the reference variable, and then we can access it inside the static area as well. And inside the non-static construct, we can use it plainly by its name. And for instance variables, right, JVM will always provide default values. Alright, this is very important point. When we create instance variables, when we declare instance variable inside the class, JVM is automatically going to provide the default values to those defined variables, instance variables, right? For example, if I define int x and then there is no equals to 10, or there is no assignment, or there is no initialization of the instance variable, then JVM by default will give int a 0 value. And to prove the point further, let's see. Yeah, we have one more example here. Class test int x double float blah 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 blah. Copying the code, and then we will go to the class test, saving the code over here. Now if I discuss the code over here, we will find it's an instance variable uninitialized. Similarly, all these are uninitialized instance variables. These are instance variables because they are not inside any method body, they are not inside any block, static or non-static, and they are not inside any kind of constructor, right? Now we have the main method static, and because we are in static context, we have to create an object reference. or an object, sorry, not an object reference. We have to create an object, and after creating the object we have to access the instance variable using the reference variable. So t.x is going to give us access to the x. When I try to print this, I will find that 0 is given by the JVM to x. So the default value for int is 0. For double is 0.0, for boolean it's false, and for float it's 0.01 second, right? It's 0, not f, it's 0.0, right? And then for string it's null, because the string is an object type, so that's why we're going to get null as the answer on the screen. Let me save this code and run this and show you that indeed the replies are same. Alright, and fine, right? 0 for int, double 0.0, boolean false, string because I am printing string first, string s, and I'm trying to use access s, right? So null is printed, and then only float I am trying to print. That's why 0.0 is in the end of the printing statements, right? So this is something about the instance variables, or I'll say a lot about the instance variables. We are going to discuss about the static variables and the local variables in the next video sessions. Thank you very much for listening, and stay tuned for more of the examples related to variables. Have a good day. Bye.